Welcome to School of Civil Engineering. In this video, I will show you that how to define wind load and also how to make the diaphragm for wind load. And if you're new to this video, you can watch the previous lecture about Etabs tutorial, and I think it will be very helpful for you. So let's start. First of all, we'll open our previous module, and in whole series I'm just using that every types of load we have applied it on it, and in this video we'll just apply wind load on it, then or every types of load applied it will be completed. So let's start. And here to define wind load, at first we have to go define, then from here load pattern. After going load pattern, I have to write here wind load in x direction, so wx. So from here type which types of load are wind load. It's wind load. Now we have to select here auto lateral load. I mean which types of code we'll use here. As in this series I'm using UBC 97, and you can use according to your country code. So I'm going to use here UBC 97, as in previous lecture I have used that for seismic. So from UBC 97 from WX, add that load and go for modify. Before that we'll also add load for y axis, so WY. So it's same again, click here add new load. So first of all select that WX, modify lateral load, and from here we have to do some work. There have two things, exposure and pressure coefficient. Exposure from extent of diaphragm, exposure from shell offset. They have two options, exposure from extents of diaphragm. If we select that option, then we have to select diaphragm. I mean we have to apply diaphragm on our building. And if we use the second option, exposure from shell object, then we have to make the shell on that building, and after that we have to define that load, but we'll use exposure from extended of diaphragm. Then here the important term wind speed of your area, you will get it from your code. And here they have exposure type. There are three types of exposure. In this code is showing B, C, D. In our code it's A, V, C. So A will be B, B will be C, and C will be D according to BNBC code, Bangladesh National Building Code. And here important factor, which types of building we are using. As in previous I have used 1.25 important factor in earthquake, then I will use that 1.25. and here exposure type B, C and D. You will find the detailed description in your code which are exposure type, I mean in which condition we'll use exposure type, which types of exposure type. So I'm going to select exposure type B according to my code. So B will be C, here C. And the one thing, exposure height, I mean from which point to which point the wind will pressure on our building. So we know that wind will start pressuring from ground to top, because in base there will no wind, because it will be covered by material or soil. So it's ground floor, and here is the important things that include parapet. Parapet is that the wall around the upper floor, I mean roof. So I will use here 3 feet or 4 feet parapet, 4 feet parapet, and we have applied it all of our load here 70C125. But if we go here, we're seeing that they have no story height, or there nothing. So before that we have to go just click on here, we'll modify that later. So click OK, and before that we have to provide diaphragm for it. So first of all, go this is the lower floor, I mean ground floor. First of all we have to select that. First of all we have to take that point, not all story, one story, then click here and select that. After that we have to go assign, then shell, and from here you will find here diaphragm. Assign, shell and diaphragm. So select D1, we can modify that D1 modify. So we have to select a rigid, not our building is semi-rigid, it's rigid. Okay, D1 okay, and here apply. Okay, we have applied it diaphragm on here, and again we'll go upper floor and we'll select apply. We'll go again upper floor, select apply, again go upper floor, select apply, again go upper floor, select and apply, again go upper floor, select and apply, again go upper floor and select and apply. Okay, the defining of our diaphragm have been completed. Then we'll go again define load pattern, wind load, modify the other value of that are okay. So from here we have to select wind speed of our area, wind speed of our area. So I'm giving here 100 mph wind speed. You have to give that value. I'm just giving that value, not exact value, I'm just giving that value to teach you so that how can you apply your value here. So after that you have to go here, now you are seeing that there have data, diaphragm data, building height, width, everything are here. So first of all, as we're assigning, you are defining the wind load here for X direction. So first of all we have to select here 0 degree. In X direction we'll select 0 degree for X direction and click OK. And here is the again check 0 degree. Okay, and here is the main important thing, windward coefficient and leeward coefficient. What is that? You will also find it from your code. What is CQ? What is CQ for windward coefficient, leeward coefficient? And I will just calculate it from an Excel sheet. So here we have to provide our length of the building along X direction, length of building along Y direction, height of the building, and here wind direction perpendicular to X. I mean in which direction when we'll provide value in x direction, then we have to click here and have to select y, because x direction are perpendicular to y, and as we are going to define the value in x direction, so this is the main direction. First, after that we have to find out our building height. So from here, if we go click OK, we'll again come here for modify. Just will take our building dimension. This is the x direction and this is the y direction. This is the y direction, this is the s direction. So according to x direction, the total building length 11.2, 20 and 7.75 feet. So total length will be 20, 30, let's calculate that. 20 plus 11.25 plus 7.75, 39. So according to x direction, the value is 39. So now we have to find out the length along y direction. In y direction it's 16 and 8, 24, and here height of the building, we'll calculate the height of the building. So here we know that from that floor or building height will be a start from that floor. So here total height will be 10 plus 10 plus 10 plus 10, 40, and here there have 8, so 48. Give here the value 48, and this is that. So after that, if we go here for final result, this is our CP 1.28. We'll give it. So again go for modify load 1.25, so 28, 1.28, and this is the Leeward coefficient CQ. This is the value when the wind will attract or wind will affect the building, then the opposite, what is the effect will be the opposite side. It's represented on Leeward coefficient. So here we'll give here 40% or 35% or 60% of windward coefficient value. So 0.5 it's okay, and also you can check your design code what they have recommendation. So after that all value are provided, again check it 0, then okay. For y direction, go for modify. Here give here 100, b, it will be 1.25, and here from GB to base parapet 4 feet, here 1.25, and here we have to modify the value. Here it will be 90 degree, it will be 90 degree, because for y direction it's 90 degree perpendicular to x direction. Then okay, then we have to again go in Excel sheet or you have to calculate your CP. So from here you have to change it that, and the other value are same, just we have to change the direction. I mean now wind direction perpendicular to x, 90 degree, here 90 degree. So final result 1.56 go here 1.56, and here we'll provide here 24% of that, so 1.56 into 0.4, 0.62 will give her 0.63. okay, done. Everything are done. Again, let's again check 90 degree 1 here, everything are okay, then okay, then again okay. So our defining of wind load are okay, then click here okay. After that we have to go for load case. Here in previous video I've told you about qx minus qx, qy minus qy. So again I'm telling you that every time wind will not only come from x direction, it will come from opposite of x direction and opposite of y direction. For that we'll just make for like that qx minus. So select that wx, add a copy of case. So from here just give here the value negative. I have detailed described in my previous video, w minus x, okay, and select wy, copy of that case, minus wy, and select here minus and click here okay. So here our load case also okay, we have defined our load case, so click okay. After that we have to do another thing, load combination. Just select that, delete wall combo, and again select for concrete frame design, concrete frame design. Click here concrete frame design, convert to user editable, okay. There have our combination for our, that's 4 types of load. Click okay. Here one thing, I have just used a default load combination according to UBC 97, but in another video I will show you that how we'll define our combination according to our code or our required combination. So our all work are done, then we'll go for analysis, and before that we'll go here, check model, select wall, okay. Warning: horizontal rigid diaphragm connection found between joint at a different elevation, please check it. So we have found a warning: horizontal rigid diaphragm connection found between joint at different elevation, okay. Click OK, and module has been checked, no warning message generated. So for that we have to go here, if we go here, there have they show warning for that, and also for that they have show us warning, so it is nothing. Now go for analyze. So our building have analyzed for our different type of load. We'll close that, and here we'll go for different shape. For which types of load we want to go here, wind load, apply for wind load, this showing that this is the deformation for wind load, and it's very low, 0.88 inch. And for WY, apply for WY. This is for WY. This is the deformation for WY. And WX, apply for WX. This is for WX. This also very low, the maximum in X direction 0.61 inch. And WY, this for WY, it's showing 0.47 maximum. So at that way we can analyze our building using the different types of load. And we can start here animation. If we start here animation, it will show us the real-time movement of the building. It's showing the real-time movement of our building when it's showing at the time of wind load in -y direction. So stop that, and that was our wind load defined. And in next video I will analyze that building and also check for design that building. So thank you very much. Stay connected, and if you are new to my channel, you can watch my previous video if you think that it's good to you. And this is not for professional, this is only for practice and educational purpose. And after completing that all tutorial, I will go for a professional, I mean a real-time project that I have learned from a construction engineer. So stay connected. Thank you very much.